project on hotel content management using YOLO object detection algorithm. Now moving on to our research question. Now this is our research question. In this we have written, how can we automate the content management system of hotel listing website using object detection methodologies. As we can see, this is a good image in which the amenities mentioned above has been listed in the images below as well. So moving on to a bad image which will define our research problem. As we can see, the owner has not updated his images according to the amenities he has mentioned above. This is a problem for the content management team which needs to be solved for the user to get the user customer satisfaction. For this, we have implemented a project on Python to automate this process and reduce the cumbersome task for the content management. Now moving on to the implementation part. We have used Python to execute our project, and we have trained the YOLO algorithm on 4 custom objects which are AC, TV, bed and disabled sign. For this we need to extract the dataset, and for that we have written a script in Python. We have used beautiful soup which is used for scraping and URL lib request to call Google Images URL. Now we have created a variable called URL base, and this is where we are going to pass our search terms, and this is where the search name variable is there, and we are going to pass the different search terms such as bed view, hotel or disability sign or TV and AC as well. Now as the images are extracted and stored in the bedroom directory or any other directory which will be created while searching the different search terms, now we need to maintain the consistency among the images which we have downloaded or extracted using this Python script. For renaming, we have used this Python script. This will rename and bring a consistent format of all the images. Moving on to the annotations part. This is the important part of our project. In this we have mentioned the image folder which will store the directory where the images are stored, and the annotations will be stored in the annotation directory. Now for that, now we are annotating suppose object called bed, and this is the generate XML file which will generate the XML automatically. In these are the variable which are xmin, ymin, xmax and ymax, which store the location of the object in the image, and these are the height, width and depth of that object in the image. Now we'll run this code and see how this is done. Now as we can see, the window screen has popped up. For this we have used the OpenCV2 library in Python. Now we are going to select the object. As we are selecting the object, we need to be particular about the object we are selecting, as it's not the TV, it's the bed. Now after selecting the object, when we press the button Q, it will automatically generate the XML file. So as I press Q now, the XML file here has been automatically generated. As we can see, the annotations of the name bed has been specified as well, and the xmin, ymin, ymax and xmax value has also been allocated. As the annotation part is completed, now we'll move on to the training process. Now in the training process, we'll go to the Darkflow master folder and we'll call the command line from here. As to start the training process, we need to call the Python script called flow using the command line interface, and the code for this is given here. In this we can see that we call the Python flow script in which we pass the model, which is the configuration file, which is the tiny YOLO VOC CFG which we have modified, and the pre-trained weights which are saved in the bin folder. We are passing our annotation files as an annotation while training the dataset, and the dataset for this we are using is the images that we have extracted. We are training this algorithm for 500 epochs and at 70% GPU rate, which means it will use 70% processing power of the GPU. Now we'll start the training process and see how it goes. Now we can see the training process is initiating and the convolution layers are being loaded. Now as we can see, we are entering the training process from here and our dataset is being loaded. Now as we can see, the training process is started. Currently at step 1 the loss is at 106, but when the epochs will be completed and around 47,500 steps, the loss rate will be minimum up to 0.1%. Now for the video purposes, we will have to stop this execution, as this model would take up to 32 hours to train. After training this algorithm, After training this algorithm, our custom weights will be generated in the CKeyPayT folder. In this, we have trained this algorithm for 47,500 steps, which took us 32 hours. Now, as the training is completed, we'll move on to the testing. So in order to ease the process of testing, we have built a UI using Bootstrap for front end and back end for PHP, and we have used Ajax for button calling purposes. Now we'll select the images and test our model. Now we are selecting the images. As the image has been selected, now I'll press the YOLO button. This will initiate the command line for testing purposes. Now as we can see, this is the script which is going to run in the background, and it will pass our testing images into the output folder, and using the show result script we will see the output. Now as we can see that we are forwarding our 16 inputs and our model is processed, and the total time it took was just 0.4 seconds. Now we'll move on to the show results part. As we can see, the input images we have passed, and these are the output images which we have received. In this, our model has accurately detected TV and bed. Moving on to further images, you can see the accuracy is maintained, and our model has perfectly detected all the objects present in the image. That was our project. Thank you.